Let me guess, you've built a few machine learning models, maybe even a lot of them. You might have even tuned a couple and got the accuracy score through the roof. But if I asked you right now, can I try one? You'd probably say something like, yeah, it's in a notebook somewhere. Well, welcome to the gap between academia and the real world. Most machine learning projects never leave the lab. They become these digital ghosts trapped in notebook limbo. Accurate, sure. Useful? Not really. And this isn't your fault at all. In fact, most people haven't been taught about production in school and have to figure it out in the real world. That's why most data science portfolios are stuffed with static notebooks, screenshots, Kaggle links, but the next step from there is building something that people can actually use. So in this video, you're going to learn how to deploy your very first machine learning model into production. But before we get into the how, we first need to talk about the what. What does deploying a model even mean? Deployment is the process of making your model accessible for real-world use. Now, it's important to understand and know the differences between a training environment and a production one. In a training environment, you're usually in control of all the variables. You know, the data might already be cleaned and curated through the ETL, and typically people do this on a local script or through notebooks. A production environment, on the other hand, is more messy. It involves real-time data. You're also going to have other constraints like latency, costs, uptime, rate limits, and selective features available. There's also going to be those annoying edge cases like missing data or invalid inputs that your model will have to handle. Think of it like baking. Training is like baking a model at home. You can try new recipes, experiment, make mistakes until you get it right. Deploying a model, on the other hand, is like opening a bakery. Now you have to serve consistent results to strangers on demand with stuff like health codes, pricing, minimizing errors in mind. So, as you're probably able to tell, a model that performs really well in a training environment might not do too well in a production one. That's why, before you even think about deployment, you need to first ask yourself a couple questions. Like, is my model even good enough? Or do we have a use case for this product? Or do we even have clean and well-engineered features at the production level? Now, don't get me wrong, your model doesn't need to be perfect, but if it has something like a 50% accuracy score, that's basically like a coin flip chance. And if your model depends on highly engineered features or crazy imputation methods that you might not be able to replicate in production, then it might not be a deployment-worthy model. Also, if you need your model to respond very quickly, then you might need to narrow down your model selection choices and avoid things like ensemble models or even neural nets. Hopefully that didn't scare you too much. It's just some real considerations that you should be aware of before productionizing a model. Anyway, once you have all your ducks in a row, it's time to get into the logistics of model deployment. Let's say you've already trained a pretty good model, you've verified that there's a real-world use case, and you also know that the features needed are available in production. The next step from here would be to package your model and all its dependencies so you can create an inference pipeline. Don't worry, I'll be doing a demo in just a second, but at a high level, you will need to store your trained model and all its dependencies like libraries used, features you need, and a scalar model if that's necessary, and to some sort of bucket. Generally, this inference pipeline will have something like an entry point and an endpoint. The entry point is where the data comes in, so think of a user putting in some inputs in a form or something like that, and that data is then sent through the inference pipeline to be cleaned, processed, scaled if needed, to feed into the model so the model can make a prediction, and that prediction is then sent back to the end user through the endpoint. A good inference pipeline will have stuff like input validation, error handling, a foolproof pre-processing function if needed, and processes to version or log your models. So now that we've run through all that, it's time for you to finally deploy your first model. Let's get right into it. All right, so this is how the final product should look like if you follow the steps. Essentially what this is just a front end where you can put in a lot of inputs that the model needs, and then you can hit predict price, and it should give you an output of the predicted price based on the prediction of the model. So as you can see, this is the specific output for the inputs that I provided. Let's start with the GitHub repo for the backend. So the backend would be the inference file. So all the resources I'm going to be using in this video are linked in the description below, and the README notes are going to be pretty helpful. So feel free to look at that too. But essentially what we're going to start off with is cloning this GitHub repo. And to do that, we're going to hit code up here and copy this and go to your desktop. If you're using Mac, open your terminal. If you're using Windows, go open your console. I'm going to be storing this on my desktop. So I'm going to be navigating to my desktop and then do cd desktop and then do git clone. Paste this. I already have this in my desktop, so I'm not gonna clone this because it's gonna throw out an error. So I'm gonna instead go to the code file itself. I'm gonna do cd house price predictor inference, and then do code dot. If you have VS Code installed, you should be able to do that too. Cool, so here we have a couple files, but first I want you to navigate to the notebook. This notebook is essentially just a notebook I got off of the Kaggle dataset where I took this from. So the Kaggle dataset I'm using is housing prices dataset. I went to code and then I chose the one with the most votes. But I did find out later on that there was a lot of, I guess, inputs from this notebook that we really don't really care about for this model. We're just trying to deploy an MVP. It doesn't have to be the best model. We just want something simple that you guys can understand and can deploy yourselves. So what we did was we trained our own model at the bottom here. I essentially imported the data set from my desktop folder, but you guys need to download the data set here yourselves and then import it. And then once you import the data set, you're gonna train the model, drop the price or the target variable. I trained 3 models, and the best one here was the gradient boosting model. So that's the one we ended up using and saving. We also had to save the pipeline. So essentially all the steps we needed to take place to actually train the model, like the features we use, if we scaled it, what scaler we use, and stuff like that. So we have to save the features, the model, and everything else. And the way we save that is through pickle files. And for those of you who don't know, you can save models through pickle or job.load files. And you can think of them as like buckets, buckets where you can store your model, or buckets where you can store your like input variables and stuff like that. So we have 2 buckets here, the model.pickle file and the features.pickle file. They're already in the GitHub repo, so you don't really have to run this code at all. But if you want to try this yourself, you can go ahead and run the cells at the bottom 3 cells, and it will run and save the features you use, the model you used. And also we also have the requirements.txt file. This is essentially all the requirements, all the libraries that we're using for the model training process. You will need this because in the pipeline, in the inference pipeline, they're gonna need the dependencies you use to train the model so that we can replicate that in production. So in this requirements.txt file, we have a lot of dependencies, but actually what we really need is just scikit-learn, FastAPI, Unicorn, and I believe pandas and NumPy. Everything else was just other libraries that were used in the notebook that we don't really need. All right, after we have that, we can go ahead and navigate to the inference.py file, which is essentially your inference pipeline, like I talked about earlier. Cool, so I'm gonna walk through this file real quick. Essentially what we're doing is we're creating a FastAPI app, and this allows you to send inputs and receive an output through this API. And FastAPI was created a couple of years ago, and it's pretty neat. I've used this for a lot of my projects in terms of machine learning deployment and other like software engineering full stack stuff. Highly recommend checking out their documentation if you want to learn more. There's a lot of videos and resources online on how you can use FastAPI for various different projects, so totally recommend you guys checking it out. So the middleware section is essentially for you to productionize this, for you to be able to use this at any point of the internet, anywhere in the world. You will need this middleware section. This part of the section allows any origin at all. However, I do recommend changing this to just a specific front-end URL that you know of, because this allows any website to invoke this API. Which can be dangerous if you don't have like rate limits and stuff like that. However, for the purposes of this tutorial, we don't really need to worry about that at all. And then this section right here just opens the pickle model of where you trained your model and saved it. So this opens that bucket I talked about earlier to load your model so that we can use it for this testing in production. And this class right here is just defined to understand the schema of what the inputs expect. So like area is a float, basement is a string, yes and no, furniture status or furnishing status is a categorical variable. So you have 3 inputs, and we're gonna define all this in the actual front end of the app. And this part right here is the actual pre-processing and predicting function. If you have a lot more steps, maybe you have imputation functions, or maybe you have scaling models and stuff like that, this is gonna be a lot longer. However, since we trained our model on very simple data that's available on the production level, on real-time level, it's gonna be pretty simple right here. We also have very basic error handling. I totally recommend if you're actually gonna productionize a model in the real world for actual use cases, do try to make your input validation and also error handling much more thought out, much more planned, just so you don't have any problems later on. But for the purposes of this deployment, you don't really have to worry about that. Cool, now that we have all this set up, we're gonna go run this just so we can test it out. I'm gonna go look at the GitHub repo to remember what command we need to run. Everything is on the GitHub repo. So we're gonna be starting the API server with a modification of this command right here. So we're gonna go Unicorn Inference app, and then we're gonna do reload. But first we're gonna run the file. Cool, after we run the file, we're gonna be starting the API server with this command right here. So Unicorn Inference semicolon app -- reload. Perfect. So now we can navigate to that page right there. Let me just copy that link, navigate right here. And then we can see that the house pricing model is live. To test this endpoint, we can do a couple things. We can use curl, we can use Postman, but the simplest way in my opinion is just going to /docs, and FastAPI has a pretty good UI for you to test it out. I'm gonna go to the post request because we're trying to send data in, and then try it out. You could use the default request body, but we have to make a couple changes because we know that inputs like main road, guest room, basement, stuff like that, those are Boolean inputs. So I'm gonna change the inputs for this specific purpose. 7420, 3, 2, yes, no, yes, no, yes. So they have 1, no, and let's do furnished. And this should give us a prediction. So the prediction here is about 1 million, I guess, Indian rupees or lakhs. I don't really know the currency the data set was created on, but it looks like it's working. So that's great. That's the first step right there. The next step from here is to actually build a simple front end so that we can, make the end user more comfortable, make the experience more friendly and stuff like that. I already have a front end built through ChatGPT and Next.js, which I'm gonna show in this video, but I also have a better front end, the one you saw at the beginning of the video, that looks like this. That was built with V0 Vercel. It's amazing, and I totally recommend you guys check it out. But for right now, we're gonna go ahead and clone this repo right here. So same steps as we did for the backend pipeline. We're gonna go to the desktop, and we're gonna do git clone, paste that repo. I'm not gonna do that because I already have it. So I'm just gonna go and navigate to that file. So house pricing app and code dot. Cool, so when you guys first open up the app or the code, this is probably what you're gonna be seeing. And for those of you who aren't familiar with what Next.js is, it's essentially React and Node. I think it's pretty easy, pretty user-friendly for beginners to get started in, especially a lot of people who are looking to build startups and build them quick. There's a lot of documentation, there's a lot of pre-built components like with ChatCN and stuff like that. So what we're gonna do here is in the terminal, we're gonna type in npm install. And what this does is it installs all the dependencies you need. It could be the specific ChatCN components, it could be the Tailwill components, or the React components. Whatever this project was built on, you're gonna do npm install. It looks like mine is already up to date, so that's great. After that, we can run npm run dev. Cool, it looks like it opened up in localhost 3001. So let's copy that and let's paste it here. And we see the basic front end. But right now, this will not work just yet, just because we haven't pointed this to the backend API that we just built. So what we need to do here is look for the handle submit function, which is a function I built that I guess handles what happens when you hit the submit button. And in this case, it sends that data to the next public API URL /predict to make a prediction and then return that prediction that we can show on the front end. So what I'm gonna do here is create a .env file in the source or the root. And in the .env file, we're gonna make a label for next public API URL. And we're gonna change this to, instead of 3000, we're gonna do 8000 because that is that's the port. And we don't need /predict because the /predict is already here. So this should work now. Let's go ahead and fill it out. Send 420, let's do 4, 3, 2, 1. Let's do predict. And here's the prediction. So that was pretty quick. However, this UI here isn't too pretty. So I'm gonna go ahead and show you how I built that front-end UI with V0. Essentially what I did was I started off my conversation with V0 with help me build UI for my backend FastAPI model, make sure that inputs are available, and then I sent it the FastAPI code that I have, just so it understands the schema of what to expect and stuff like that. And then after a couple back and forths, it got me to this website right here. So looks pretty nice, and the code is all here. And for you to install this code, you just have to go up here and type this in your Next.js project. However, I already have that pushed into a GitHub repo, so I'm not gonna do that for this video. Cool, now that we have all that done, the next step from here is deployment. Just because we can do this in localhost, which is what we have been doing, the predictions and also the UI, that doesn't mean everyone else, all the other users who might want to access our app can access it, which is why we need to deploy this so that other people can access this. And for this video, I'm going to deploy it with Render and Vercel, but there are a ton of different options. You can use Docker, you can use SageMaker, you can use ECS, you can use Railway. There's a lot of different options for you out there. However, I found that using stuff like Vercel and Render were pretty simple for me to learn, so I plan on sharing that with you guys today. What you're gonna need here is a GitHub account, a Render account, and a Vercel account. And don't worry, it's pretty easy to set up. I'm gonna go navigate to render.com. So we're gonna deploy the backend first. What you're gonna do is sign up, create an account, and once you have an account, you're gonna go up to the top right, hit new, and then do web service, which is essentially what we're doing. And then you should find your repo right here, whatever repo you've pushed your GitHub project to. In my case, it's the house price predictor inference. You might have a different name. If you don't see your project up here, you're gonna wanna configure your render instance to allow more GitHub repos. And you might have to communicate with GitHub and allow all public repos or select repos, whatever might work for you. But I'm just gonna click this right here. You can name this whatever you want to name this. I'm going to name this v2 because I think I already have an instance. The language we're using is Python 3, but this allows, or this works with Docker, Go, Ruby, whatever you might be interested in. And the branch, we only have one branch for this repo, so it's going to be main. But if you do have multiple branches, you can select the branch you desire. The root directory, since we don't have any files where the main file or the inference pipeline is nested in, it's going to be in the root directory, so we don't need to fill this up. Now the build command is pretty important. This is the command you want to run upon build. And since we have dependencies like NumPy, scikit-learn, uvicore, and FastAPI, we need it to run the requirements.txt file. So the command there, it's pip install r requirements.txt. This is just the default boilerplate, but you can also add other commands here if needed. Now the start command is the command you need render to run upon starting your app. And the start command is located in the GitHub repo. It's the start API server command. It's going to be uvicorn, inference app, host, and your port. So let's just paste that right here. If, for example, you named your file main.py instead of inference.py, you're going to change this to main. However, since our file is named inference.py, and if you follow the tutorial, if you copy the same GitHub repo, you should be completely fine. And then down here, since this is just a hobby project, we don't really expect a lot of users. We don't expect a lot of CPU usage. And we don't need the, I guess, inference time or the latency to be very fast. We're just gonna go for the free, but they also have, starter plans, standard plans, and stuff like that. So feel free to check it out if you're looking to scale or do something more complicated. And then down here, you're gonna put in any environment variables that you need. For this case, we don't need any environment variables. We're not really calling any other APIs. You don't have a dashboard. We don't have any authentication service. So we're not gonna worry about that for this project. And then the advanced settings, there's a lot of stuff here that you can mess with, but I'm not gonna mess with anything for this specific project too. Cool, once you're done with that, you're gonna hit deploy web service. And then up here, mine's gonna be blurb. Up here, this should be the API URL that you're gonna copy and paste into your environment folder when you deploy your front end. And if this is all confusing to you, don't worry, I'll walk you through it step by step. So this is gonna take a couple minutes to load and build. So I'm gonna start off with the Vercel deployment. You're gonna go navigate to vercel.com. So once you get to Vercel's homepage, what you're gonna do is either log in or sign up. I already have an account, so I'm gonna sign in with GitHub, but you can do the same thing with your own GitHub account, which is what I recommend. So once you're signed in, you should be able to navigate to the projects page, which is where I'm at right now. So if you don't see your project on this page, what you're gonna do is import third-party Git repositories and paste your GitHub repo URL. And this has an assumption that your repo is public. If it's private, then you're probably gonna have to configure your GitHub preferences or your authorization within GitHub itself to allow Vercel to access that specific repo. Since my repo is right here, I'm just gonna hit import. And we don't have to mess with anything except the environment variable. As you know, we have the next public API URL environment, and we need to input the value, which we can get from render. So if you go to render, we can see that this is deployed successfully. We're gonna go ahead and copy the API key and then paste it right here. Then hit deploy. And this should take a couple minutes to deploy. But in the meantime, we can test out if the deployed backend API key works by going into our front-end code and changing the next public API URL to that new link. And then let's run npm run dev. And then we can navigate to that front-end page again. So this is still localhost, but the backend API is not deployed publicly. So let's do 7420. Let's do 4, 3, 2, 1, and then leave everything else as default. Then we see this work just fine. Now, while this is loading, I want to emphasize how important it is to not expose your API keys or any of your environment variables to anyone publicly. And how you can do that is adding a gitignore file so you don't accidentally push your environment variables into GitHub or any other Git repository. Cool, it looks like this launched successfully. Let's continue to dashboard, and we can then go ahead and navigate to that URL. Perfect, this is the front end that I told you Vercel v0 built. So it's pretty neat. There's a lot of different tabs. the inputs are predefined. There's input validation, there's some basic error handling, and there's also predefined metrics inputs. I'm just gonna go with the luxury villa for now. And then we see we get a predicted house price with the luxury villa. Let's try something else. Let's try the budget home. You also get a predicted price there. So perfect. If you followed the tutorial, hopefully you deployed your first machine learning project. If you go ahead and copy this link here, you can send it to anyone and they should be able to access this link. Obviously, for personal projects, it's totally fine having a Vercel link. However, if you're building something seriously for your own business or something like that, you can go ahead and create a custom domain through websites like GoDaddy or Google Domains or Store and create a custom domain and link that to Vercel. So it looks a little bit more professional, but everything else is done exactly the same. Like I said, this UI right here was created by V0, so go check it out. I'll leave a link down in the description box below. Personally, I'm not a big fan of creating a lot of software engineering or front-end components to build pretty UI or center div and stuff like that. I'd rather have V0 or AI do it for me, which is why I highly encourage leveraging tools like this to help you focus on what matters to you. I know a lot of people might think that the data science role ends at training and testing models locally. However, these days, there's a lot of roles that require you to have experience deploying models. So something like this will definitely help you out a lot. Traditionally, stuff like machine learning operations is left to machine learning engineers or cloud ops to handle, but these days it's much better to have a full stack experience so that you can boost yourself and make yourself more marketable. Anyway, that's about it for this video. If you guys liked it, do let me know in the comment section down below and do consider subscribing too. If you want a full checklist of what you should be aware of before deploying a model, let me know down in the comment section below too. Also, if you want to learn how I built and deployed a full machine learning app in 24 hours, you might want to check out this video.